Every night, when you look up at the sky, you might see tiny dots of light moving steadily across the stars. Those are satellites, human-made machines silently circling our planet. But have you ever wondered how they stay up there without falling back to Earth? Let's find out. To understand this, we first need to look at two powerful forces: gravity and motion. Gravity is what pulls everything toward the center of the Earth. It's the same reason a ball you throw into the air comes back down. But satellites don't fall like that, because they're moving extremely fast sideways. Not just upward. That sideways motion creates something amazing called orbit. Imagine swinging a ball tied to a string around your head. The string constantly pulls the ball toward you, while the ball's motion tries to move it outward. These two forces balance each other, keeping the ball circling smoothly. A satellite works in almost the same way. Gravity acts like the string, pulling it toward Earth, while the satellite's speed keeps it moving forward around the planet. When a satellite is first launched, a rocket carries it high above the atmosphere. Once it reaches a certain altitude and speed, the rocket releases it into orbit. At that point, gravity is still pulling it down, but its forward speed is so great that it keeps missing Earth, and that is how it stays in orbit. In simple terms, satellites are always falling toward Earth. But because the planet is round and they're moving fast enough, they keep falling around it instead of into it. There are different types of orbits. Some satellites move in low Earth orbit, just a few hundred kilometers above us. These are used for things like weather monitoring, photography, and the International Space Station. Others are much higher, in what's called geostationary orbit, about 36,000 kilometers above Earth. At that distance, they move at the same speed that Earth rotates. So they always stay above the same spot on the ground. That's why TV and communication satellites don't appear to move in the sky. Maintaining these orbits isn't easy. Even the tiniest bit of air resistance or gravitational tug from the moon and sun can slowly change a satellite's path. Engineers use small onboard thrusters, like tiny rocket engines, to make occasional adjustments and keep them on track. They also carefully calculate the exact launch angle and velocity before sending one into space, because even a small mistake can cause a satellite to drift, burn up, or float away. Satellites have changed life on Earth in countless ways. They help us navigate with GPS, forecast the weather, transmit television and internet signals, and even monitor climate change. Many of the conveniences we rely on daily depend on these silent orbiting machines that balance perfectly between gravity and speed. So next time you spot a moving light in the night sky, remember, it's not magic. It's physics, precision, and human curiosity working together, keeping satellites gracefully spinning high above us. Comment the next topic you want to learn.